When transitioning from an old TSX21 PLC to a new Siemens PLC, understanding the connector mapping is crucial. This ensures a seamless migration without disrupting the operational environment. Imagine you're replacing a complex machine part without a blueprint, you'd likely face numerous issues. Similarly, without knowing the exact mapping of the 37-pin connectors, you risk miswiring and operational failures. The TSX21, with its two 37-pin connectors, needs precise mapping to avoid extensive testing and potential downtime. This leads us to the necessity of detailed connector documentation and the strategic approach to PLC replacement. Understanding the TSX21 connector pinout is crucial for a seamless transition to a new PLC. Each of the 37 pins on the connectors has a specific function, ranging from input and output signals to power and ground connections. For instance, pins 1 through 10 are typically designated for digital inputs, while pins 11 to 20 might be for digital outputs. It's essential to map these accurately to ensure that your new PLC, like the Siemens model, can interface correctly with existing hardware. Misidentifying a pin could lead to malfunctions or even damage to the equipment. To avoid this, you should cross-reference the pin functions with the device documentation and, if possible, use a multimeter to verify the connections. Remember, precision here is not just a preference, it's a necessity. Converting TSX21 software to a new PLC involves a meticulous process. First, identify the existing software structure and parameters. Next, map these parameters to the new PLC's equivalents. Use Schneider's conversion tools for automated migration where possible. For manual adjustments, consult the new PLC's documentation. Ensure that all I/O mappings, timers, and counters are accurately translated. Test the converted software in a simulated environment before deployment. This reduces the risk of operational disruptions. Remember, the goal is to maintain the same functionality while leveraging the new PLC's capabilities. Now, let's dive into the practical steps for transitioning from a TSX21 to a Siemens PLC. First, identify the mapping of the 37-pin connectors on the TSX21. This is crucial for understanding how the sensors and actuators are connected. Next, document every connection point meticulously. Use a spreadsheet to list each pin, its function, and the corresponding device. This documentation will serve as your blueprint for the new setup. Once you have the mapping, you'll need to rewrite the software for the Siemens PLC. Utilize Siemens TIA Portal for this task. Import the documented connections into the new PLC's configuration. Pay close attention to the input and output addresses, as they may differ from the TSX21. After configuring the hardware, proceed to migrate the logic. If you have the original TSX21 program, consider using a conversion tool if available. Otherwise, manually translate the logic into the Siemens environment. Test each segment of the logic to ensure it functions as expected. Finally, perform a comprehensive system test to verify that all connections and logic work seamlessly with the new Siemens PLC. Now, let's delve into the advanced considerations you must keep in mind during a PLC replacement. First, understand that the mapping of connectors is critical. In the case of the TSX21, knowing the exact pinout of the 37-pin connectors can save you from extensive field testing. This is why obtaining the connector mapping is essential. Additionally, when replacing a PLC, you'll invariably need to rewrite the software. This is a non-negotiable aspect of the process. You must be prepared for potential conflicts with clients during the commissioning phase. It's also worth noting that there are tools available for automatic conversion of older PLC programs to newer versions, which can significantly ease the transition. For instance, the PL7_2 software can be used to program the TSX21, and there are conversion tools to update the program to PL7. This can be a more cost-effective and simpler solution than starting from scratch. Remember, the goal is to minimize downtime and ensure a smooth transition. This leads us to consider the importance of having a detailed plan and backup strategies in place before initiating the replacement process. And here's why that matters. When replacing a PLC, you're not just swapping hardware, you're navigating a complex web of dependencies. One common pitfall is underestimating the importance of connector mapping. Without a detailed map, you risk miswiring and extended downtime. Another critical issue is software migration. Rewriting the entire software from scratch is often necessary, but it can lead to functionality gaps if not meticulously planned. Also, be wary of overlooking the need for thorough testing. Even a seemingly minor change can have cascading effects on the entire system. To avoid these pitfalls, always start with a comprehensive audit of the existing system, document every step, and engage stakeholders early in the process. This leads us to our final point. Remember, knowledge is your greatest asset. By understanding these common pitfalls, you're already ahead of the curve. If you want to master this completely for free, subscribe so you don't miss the next deep dive. This is the kind of knowledge others charge thousands for, but here it's yours.